Hi everyone and welcome back here on the channel. Today I'm going to test a new technology inside this battery, a self-heating LiFePO battery. WattCycle sent me these little jewels. There is a new technology inside this battery, self-heating system controlled by the brain of this battery, the BMS. Thanks to an integrated sensor, the BMS can read the temperature and providing itself to self-heating the battery. It's really important for me to test this new type of technology, a self-heating battery, because I need to power up my pump for the water system during the winter, and we are going to have -6, -9, -10 during the winter and snow. So we are high in the mountains, 1,300 meters above the sea. It's a 12 volt 100 ampere per hour battery, dual purpose, not recommended for starting car, but for the off-grid project, yes. It's a little bit bigger than normal due to the integrated self-heating system. It's really light, 11 kilos of weight. And now I'm going to install this stuff in its new house. Okay, this closet will host the battery for all the winter long, but to test this battery I need the other part of the system. WattCycle sent me a solar charge regulator to assemble a single brand system, and yesterday night, hidden in my workshop, I assembled the new parts, and I'm going to explain you how to use and install this system. First, I built a small wooden frame to support the charge controller. I covered the wood with an aluminum sheet to insulate it from the controller's heat sink, even if the system will run well below its maximum power. I added a DIN rail to hold the 12 volt distribution, the fuses for the battery and the solar panel, and the main breaker for the panels. I wired everything in a clean and simple way. The diagram of the controller is very clear, you just follow positive and negative. I use a 4 square millimeter solar cable for the panels and the battery, and a 2.5 square millimeters cable for the 12 volts line. There is a 30 ampere fuse for the water pump and a 40 ampere fuse for the solar panels. I also used crimped cable lugs to ensure the best contact surface. Finally, I built a rustic wooden door to close and protect the system. Okay, this is the WattCycle solar charge controller. They sent me this to charge the self-heating battery. The wiring are completed. Here we have my water system pump cabled and the fuse of the pump. Here we have the battery and the fuse of the battery, fuse of for the solar panels, and the main switch. Wiring battery. negative and positive. Okay, this button is nice because we wake up the battery in every conditions. Of course, the battery has the Bluetooth connection. It's a nice layout. Temperature of the battery, charging, discharging, some information. 43%. So you can check and control the battery via Bluetooth connection. Okay, the solar charge controller is powered up. Okay, the system is completely running. There is no sound to test the charge controller, but why am I so interested in this type of technology? Because in an environment like this, it's important to know how and when you can charge a LiFePO battery. You can't charge this type of battery under 0.5 degrees. It depends from the battery, because you will damage the battery. So the self-heating system is the solution, in my opinion. I was a technician, a specialized technician in my past job, and so it's important to keep the battery in the right at the right temperature. In this case, WattCycle gave me this dual purpose 12 volt 100 ampere per hour. I leave you all the information in the description, link and what else. So I want to thank WattCycle to give me this battery, and I will update the description during the winter, the description of this video during the winter about the use of this self-heating battery. I hope this kind of video help you to know about this new technology. I think it will be perfect for outdoor users and camp van, everything in an environment outdoor. So thank you for watching, and see you on the next video.